Hello, I'm Miles Tails Prower. We will learn about the Doppler effect. The Doppler effect is the change in frequency of a wave in relation to an observer who is moving relative to the wave source. It is named after the Austrian physicist Christian Doppler, who described the phenomenon in 1842. You know, these circles would represent as sound waves. When it moves on either side, the sound waves would likely to differ. For example, the sound of bullet train in Japan travels at 500 km per hour. Another example, like passing truck with horn. The pitch varies due to its velocity of any moving vehicles. Suppose I was an observer, taking a video of a Doppler effect. The first pitch was maximum as the sound of a horn. When it passes us, the pitch of the horn decreases. It depends on its change in wavelengths. Any vehicle passes by would change the pitch of the horn, but decreases. Or its wavelength would increase. To denote this formula, the speeds of source and the receiver relative to the medium are lower than the velocity of waves in the medium. The relationship between observed frequency f and emitted frequency f0 is given by f equals c plus or minus vr divided by c plus or minus vs the whole times f0, where f is the new frequency obtained from the original frequency f0. C is the propagation speed of waves in the medium. Vr is the speed of the receiver relative to the medium, added to see if the receiver is moving towards the source, subtracted if the receiver is moving away from the source. And Vs is the speed of the source relative to the medium, added to see if the source is moving away from the receiver, subtracted if the source is moving towards the receiver. Equivalently, under the assumption that the source is either directly approaching or receding from the observer, the formula is f divided by wave velocity of receiver equal to f0 divided by wave velocity source equal to 1 by lambda, where lambda denotes its wavelength of sound waves. For example, the change in frequency is 80 Hz from original frequency 400 Hz. The new frequency obtained as 320 Hz. If the speed of the receiver is 0 and the speed of source is equal to the sound wave 0.5 times c, where positive sign in the denominator means an observer behind the source will hear a lower frequency, it is 0.66 times original frequency. If it's negative, an observer in front of the source will hear a higher frequency, it's 2 times the original frequency. If the source is stationary, then its obtained frequency will be equal to original frequency. It is no change in the frequency. For breaking the sound barrier, its speed of source equal to c. The higher frequency would be infinity times f0, and the lower frequency is 0.5 times f0. And for supersonic, the speed of source is greater than 1. Faster the sound waves travel. Just like Sonic the Hedgehog runs so fast in supersonic speed. I hope you now know how to find the Doppler effect. Like, comment, and subscribe now.